All right, welcome. Hello, everybody. Welcome to another virtual session of AP Biology. It's Providence here. I hope everybody's feeling okay and staying safe this week. We're going to jump right into our next online virtual teacher-guided PowerPoint lesson, where I'm going to be introducing you to something called phylogenies and cladograms. Basically, this is going to work just like it would be if we were in class. You should have your notebook with you and taking notes while you watch this. I'm going to be doing some annotations and all of that good stuff, and you're welcome to write those down as you watch, okay? Our learning target today, I can interpret and construct a cladogram and a phylogenetic tree, okay? In this mini lesson, you're going to learn how to interpret the cladogram, and then in the lab that you do after this and during tomorrow's lesson, you're going to learn how to construct cladograms and phylogenetic trees. Oops, sorry. When we construct cladograms and phylogenetic trees, what we are doing is we are building a tool that we can use to display the evolutionary relationships between species over time. And cladograms and phylogenetic trees are super similar, and they're both just ways to display this information. I'm going to show you what that is now. Okay, so couple key vocabulary words that we need to go over as we get started. Number one, you're going to hear this word a lot, this word phylogeny. And when we talk about a species phylogeny, what we're talking about is the evolutionary history of that species. So we're talking about the story that we have based on pieces of evidence that explain how that species diverged from other species over time. And the way that we communicate a species phylogeny is in a phylogenetic tree or a cladogram. Phylogenetic trees or tree diagrams, and then these cladograms, these are just diagrams that represent evolutionary relationships among organisms and species. And they show the ways in which species are related by common ancestors over time. We're going to learn all about common ancestors this week and next week. So if that word feels a little bit unfamiliar, don't worry, we're going to review it today. Cladograms also show evolutionary relationships among organisms. The only difference is that a cladogram just has a slightly different structure than a phylogenetic tree does, and we'll review that in a minute. In these examples over here of cladograms and phylogenetic trees, you can see a couple of important things. At the top of each of those are the names of the species that we're looking at. And then you'll notice that each of those species branch off from one another, and we're going to review what those branching points are in just a second. Okay, let's take a look at this image in a little bit of a larger font so you can see. So here we have at the top our focus species. And these focus species over here are the same as the ones over here, okay? And what we need to notice here is that some species are closer together and they're more recently linked together by different points on the diagrams than others, okay? On our cladogram, for example, you can see that salmon and lizards here, right at the top, are very closely linked together. And they're a little bit distant from something called a lamprey and from something called a shark. Okay, and so what this cladogram is showing us is that right here, this blue dot that I'm drawing is a recent common ancestral species that diverged to create both the salmon species and lizard species over time. Okay, these two species share a more distant common ancestor with sharks and an even more distant common ancestor with a species called lamprey. Okay, now this phylogenetic tree over here is showing the same exact information, except the phylogenetic tree takes time into account. You'll notice that these different lines are different lengths, and it is because each of those lines represents the passage of time, showing how long or how distantly in time different common ancestors are. I'm going to show you what I mean by that. Phylogenetic trees show the best hypotheses we have for how species diverge and are related to one another. And so what that means is that we use a bunch of pieces of evidence, DNA evidence, morphological or physical evidence, as well as the fossil record, which we're going to learn a ton about on Friday. We use all of these pieces to get together to figure out what the best hypothesis is to explain how different species are related by common ancestors over evolutionary time. And what we try to do is we try to go for the most parsimonious or the most simple hypothesis that we can. And you're going to learn all about parsimony in the lab that you do today. Okay? Let's take a look at how to read or interpret a phylogenetic tree or a diagram or a cladogram, okay? So you'll notice that at the top here are our species of interest. These are typically species that we would refer to as modern day species. They are typically alive today, unless we are looking at a diagram of extinct species, okay? And you'll notice that each of these species is connected to a branch, all right? We use a lot of tree lingo here. It makes it kind of simple and easy to explain. And each of these branches extends out from these different branch points, these different nodes on each part of the tree. And these different branch points represent common ancestors. When we talk about most recent common ancestors, we really often use the acronym MRCA, most recent common ancestor. And each of these different nodes, each of these different branch points represent the common ancestors that unite all of the species up here. And when we start at the end here, this mimics the passing of time. And we go from the ancestors that might be extinct all the way up to the present day species, okay? We can see here, for example, that this dot here, this node, represents the most recent common ancestor of species A and B. And we have to go back to a more distant ancestor to find the most recent common ancestor of species A, B, C, and D. And we have to go back even further to find the most recent common ancestor of all 5 of our interest species. And you can see on the diagram that E is more further related, more distantly related than the rest of these species based on the way that the branch diagram plays out, okay? When we talk about relatedness and trying to understand which species are most closely related, we can tell that using these diagrams. 2 species are more closely related if they have a more recent common ancestor, and they're less closely related if they have a less recent common ancestor. So, for example, we would posit that species A and B have a more recent common ancestor than species B and C do. And that's because species B and C share a common ancestor that is further in the past than species A and B do. This makes a lot of sense if you think about the structure of your own family. If you have a sibling, for example, me and my brother, our most recent common ancestor is our parents, our mom and our dad, right? And so we would say that we're very closely related. We have a really recent most common ancestor. It would be our parents. But if I wanted to look at how closely related I am to my cousins, for example, well, the most recent common ancestor I share with my cousins is actually my grandparents. So I would say that I am less closely related to my cousins than I am to my siblings because I share a less recent most common ancestor. It works the same way for species in evolutionary history. The last thing we want to take a look at is some key vocab here. Monophyletic groups, paraphyletic groups, and polyphyletic groups. And all of these words are defined for you on the next page. You'll notice that a monophyletic group includes a most recent common ancestor plus all of the descendants of that most recent common ancestor. This is really helpful because it helps us talk about very closely related species. We can group them into monophyletic groups. Paraphyletic groups are a little bit different. It includes a most recent common ancestor and some of the descendants, but not all of them. So this most recent common ancestor plus species B and C make up a paraphyletic group, but we do not have a monophyletic group here because we are leaving out species A. The last thing we have is a polyphyletic group. Polyphyletic groups include groups of species that are not closely related by a recent common ancestor. You'll notice that the most recent common ancestor of those 2 organisms is those 3 species is all the way down here. So they are not very closely related. That is a polyphyletic group. All of those definitions are laid out here really, really clearly. We have paraphyletic, polyphyletic, and monophyletic group, okay? You can pause and write down these definitions if that will be helpful to you. This right here is a very clear example that shows recent common ancestors and relationships between species in that we would refer to as dinosaurs. So most of these species are extinct, but this cladogram is really helpful because it shows us how birds, are what we know of as common day birds, are very closely evolutionary related to ancient dinosaur species. And this cladogram was built using mostly fossil and DNA evidence. And you're going to learn about that today, tomorrow, and Friday. So what are you doing today? Make sure that you check the daily agenda. That is very, very important, okay? First, I want to make some edits here. After this PowerPoint, you are not going to complete a practice sheet. We have replaced the practice sheet with various parts of the lab instead. What you're going to do is after this PowerPoint, you are going to open up the link to the NOVA lab and Wednesday's portion of the lab, okay? And then finally, the last thing you're going to do is you're going to complete today's learning target tracker. And you can find all of this information on the daily agenda for today. All right, folks, that is all I have for now. If you have any questions for me, please email me. I will definitely answer. You can also check into office hours. But until then, I will see you later. Have a great day. Bye-bye.